Hello, today we're gonna talk about 8 queens chess problem, which is one of the classic computational problem which can be solved by recursive backtracking. So the problem is we have a 8 by 8 chessboard and we need to find whether it's possible to place any two queens such that no two queens attack each other. So here is one example of possible arrangements of the 8 queens such that no two queens or any of the queens attack any of the other ones. So here uh, is the 8 by 8 chessboard, and here is one arrangements of that particular one of the solution. So we need to actually find the coordinate of such arrangements of the queens in the 8 by 8 chessboard. So one way to represent them in a computer program is to place the queen's position in a one-dimensional array. Suppose here we have an variable array which is called row, and the row I, which means that we are having the row in the index. So row I means that in the column I we have a row position of that particular queen. So suppose here row 13572 064, that means at row index 0 the position of the queen is 1. So at index 0, column index 0, and in row position 1 we have the first queen. So q0, you see it is placed in index 0 and row position 1. So at row 1 and column 0 we have the first queen in such possible arrangements. So the the next position of the next queen is at column index 1 and row position 3. So at row position 3 for the column 1 we have the next queen which doesn't attack the previous queen. So and similarly for the row positions 5, 7, 2, 0, 6, 4, for the column indexes 2 to 7, we have respectively we have the queen's positions that indicates that any two queens doesn't attack one another, and any such solution to the problem is having a complexity about 8 factorial, which is uh, quite better than a solution which is an exhaustive search of about 8 by 8 in a 8 by 8 grid, and rather than having an exhaustive search of 8 to the power 8, which is a quite large number, we can minimize the search space and find a particular solution to this problem of about 8 factorial. So here is one of the possible program which indicates a solution to this problem. So we have some global variables started with. So row 8, which we have the which can have the output of all such possible arrangements of the queens that doesn't attack each other. So and we can have a placeholder variables for the test case, the number of test cases, and the row position or column position, and also the line counter, which is for having how many lines we are iterating through in our solution. So one helper function that we can use is the bool, which is so this function will tell us whether in that particular row and column position that queen can be placed. So this function works by iteratively going through all the previous column. um, so so first we place, suppose we first place a queen in one of the position there in column 0 and index column 0 and row position 1, and then we iterate through all the previous columns for the next one. So we iterate through all the previous position of the queens and check whether the next queen can attack the previous queen. So this condition is checking whether that particular position of the queen can does attack it diagonally or share the same row on the chessboard. So checking the row position or whether they share the same row, we check with the condition by checking whether in our variable uh, uh, the previous row position of the previous queen is same as the row position of the current queen, and check the dimensional position whether they are equal. So if they are equal, then we cannot place the next queen in that slot in that same coordinate. So, and then if that condition meets, then we return false. That means we cannot place that queen in that particular row or column. So otherwise we can return true. So we checked the all previous position. We checked whether the previous placed queen with the current row arrangements, and check whether it can be placed. The next queen can be placed in the 8x8 chessboard. So the main operator function that is doing the processing here is the backtrack function, which takes the column position and checks whether that column position that particular coordinate has a queen on it. So if it has a queen, then we check whether then we output the position of the queen here iteratively running through the array to up to about 1 to 8 rows, and then similarly we check for the 8 rows, we check whether we can place that queen in that particular row and column. So we call that function place RC. We place RC, that means we're checking whether we can place that queen on that particular row and column on the chessboard. So if we can place it, then we put that queen on the row array, which is our output for the particular queen we are checking for. So we place that in the column index, and then we place the row position of that queen in that particular array. So and then we recursively call the function backtrack to check. We place the queen in that particular array, and we backtrack to check for the next column. So we recursively check each column one by one. So we iteratively loop through the 8 rows, and for that particular column position we iteratively loop through all the rows and check whether that particular queen can be placed in that row or column position. So the main operator function is to have the number of test cases that we want to run, and we take the parameter whether how many row or column we take from the user the input of the rows and columns, and then we initialize or create a variable of the output variable, which is row, so that we initialize all of the output to zeros to begin with, and then we start with the first position of the queen, which is 0. So backtrack function is called with the initial position of the column position of the queen 0, and we generate all possible 8 factorial candidate solutions by calling the backtrack function and iterate through each position and find all the output or arrangements of the queens in an 8 by 8 chessboard. So this program outputs the solution in a for an 8 by 8 chessboard in about 8 factorial time, and for the space complexity should be around 8 by for such a problem is suppose here we have for an 8 rows is about just an order of n for the space complexity, and the time complexity is about 8 factorial. So if you want to run it on a computer, please go ahead and try it out. Thank you.